Hi, today is December 16th, 2024. We will continue to talk about Python basics. Today, we will talk about building data structures in Python. So first, take a look at this table. There are 4 commonly used data structures in Python: list, tuple, dictionary, and set. So lists are ordered and mutable data collections in Python. Ordered means the ordering of elements matters. And also, you can use indexes to extract elements from a list. Immutable means the content and the size of a list can be changed. Let's see some examples. First, let's create a list. Just call it L1, which is equal to 2, 3, 5, and 7. So you see that if you want to create a list, you should use square brackets and separate the elements by comma. Let's take a look at L1. And then lists have features and methods associated with it. So one important feature of a list is the length of it, because lists are one-dimensional. So it only makes sense to measure the length of. We can use the len function to check the length of a list. Let's see, the length is 4. And lists also have some methods. For example, we can append one value at the end of a list. We can use the append method. For example, let's add a value 11 at the end of L1. And then let's check L1. So one element is appended to L1. So you see that the method function will actually change the original object, the list. Sometimes we want to combine lists together or concatenate lists together. Let's see how to do it. First, let's define a new list. Then, let's try to concatenate them together. We can use the plus operator. You see, it's very simple. But just pay attention. This addition or concatenate will not change L1. So let's check L1 again. So L1 still has 5 elements. It hasn't been changed since we used the append function on it. And lists can be sorted. Sort is a method for lists. Let's create a new list. Apparently, it is not ordered. Now let's apply the sort function. We don't need to put anything in between the parentheses. So see, it's sorted. The sort method changed L3. And one more important feature of lists is that it's a compound object, which means the components of a list can be of different data types and different shapes. So let's see one example. Create a new list like this. So the first element is an integer 1. The second element is a character string. And the third element is a list. So this is completely fine. Okay, no problem, no error. However, you cannot sort a list with different data types. For example, let's try to sort it. And you see there is an error message. So less than is not supported between instances of string and integer. Right, so ABC is a string and 1 is an integer. Python doesn't know how to order them. So sort is not allowed for compound lists. Next, let's see how to index and slice a list. So for example, let's pull out the first element of L1. Is 2, right? Remember, Python's index is 0-based. So the first element has index 0. And similarly, we can extract the second element of L1. And Python also has negative indexes. So the last element of a list has negative index, -1. So let's take a look at L1 again. So the last element is 11, right? So now let's try to extract the last one using a negative index. So -1. So you see it's 11. Similarly, the second to the last element can be indexed by -2. All right. Next, let's talk about slicing. Slicing means accessing multiple values in sublists It uses a column to indicate the start point and end point of the subarray. For example, let's pull out the first three elements of L1. We can use the following syntax. L1, 0, colon 3. So just pay attention. The starting point is included in the result, but the end point is not included in the result. So the index 3, which is 7, will not be included. If we leave out the start index, 0 is assumed. So we can also do the following to pull out the first three elements. Similarly, if we want to omit the endpoint, for example, we want to pull out the element from the second one to the last one, we can do the following. From the second to the last. In summary, we can use square brackets to index or slice a list. Next, tuples. Tuples are similar to lists, but there are two major differences. First, when we define a tuple, we need to use parentheses rather than square brackets. Secondly, tuples are immutable, which means their size and contents cannot be changed. Let's create a tuple first. Use parentheses. So see, it's a tuple. We also use comma to separate elements. And tuples are one-dimensional also. So we can also use the length function to check the length of it. So tuples are immutable. We cannot change any element of a tuple, and we cannot add or remove elements from a tuple. Let's see. Suppose we want to add one element to T. So see, we got an error message. Tuple objects has no attribute append. So in Python, different objects have different attributes associated with them. Tuple does not have the append method at all, so it won't work. Similarly, if we want to change the element, for example, change the value of the first element from 1 to, originally it was 1. If we want to change it to 0, so see, we got this message. Tuple object does not support item assignment. You cannot assign a new value to an item. So this is a tuple. Next, let's take a look at dictionaries. So they are mappings of keys to values, and you need to use curly braces to wrap those key value pairs. Let's create a very simple dictionary. All right. So see, when we create a dictionary, we need to specify these key value pairs. The first term is a key, and the second term is a value. And we separate these pairs by commas. And we need to use curly braces. The dictionaries are very flexible. For example, you can add a pair to it. So let's see one example. Let's add one pair at the end of students. Okay, so see, a new pair is added to the end. Items in a dictionary can be accessed through key values. So previously, when we do indexing or slicing, we use the indexes, zero-based indexes. But in a dictionary, we should use the keys to index or subset data. For example, if we want to access the value of the second pair, we can do the following. You see, Jimmy is the second value. All right, that's all about dictionary. Now let's move on to sets. So sets are unordered collections of unique items. So which means ordering does not matter for those elements. And a set can only contain unique values. So let's see a few examples. So first, let's create two sets. We first create a set of prime numbers. Oh, by the way, we should use curly braces to wrap the elements. And then we create another set which contains some odd numbers. So I intentionally added one repeat value for 1. Okay. So now let's print both of them. So first print primes, okay. And then let's print odds. So see, automatically the repeated value was removed because by definition, a set cannot contain repeated values. And now let's take a look at some set operations. So there are a few basic set operations. You probably are already very familiar with them. The first one is union, which means you pour all of the elements of two sets together. In Python, there are two ways to do union. First is to use an operator. For example, suppose we want to find the union of primes and odds. We can just use the vertical bar operator. So this means union. And you see, pay attention, the union of two sets is still a set, so it does not contain any repeated values. This is consistent to the definition of union in probability. Alternatively, we can use the union method. For example, we can take primes, then dot union, and add odds. Okay, run it. We get the same result, right? So this is a dot method. And you take one object and then dot method and then add the other object. What if we take odds first and then apply the union method and then primes? As you see, we get exactly the same result. Okay, so union is a symmetric operation. It doesn't matter which set you first specify. All right. Next, intersection. In Python, we can use the AND operator to find the intersection. So see, intersection can be found in this way. Alternatively, you can use the intersection method. Okay. And again, this is symmetric. We can do the following: odds dot intersection primes and get the same result. And then let's talk about set differences. So let's copy it here to remind us what the two sets are. So now let's calculate the difference between primes and odds. We can use the minus operator. So this means primes minus odds. Okay, let's see what happens too. Okay, so we know that the intersection between primes and odds are 3, 5, and 7. So set difference between primes and odds is just like taking the prime set and remove the intersection between primes and odds from primes. And whatever left is the set difference between primes and odds. So it's somehow like removing any elements in odds from the primes set. And then let's check if we take odds first, what happens. Okay. Apparently the result is different. So it works in this way. Take odds, the odds set, and remove any elements from primes from it. So 2, 3, 5, 7 will be removed. Of course, 2 is not there, but 3, 5, 7 will be removed from odds. And also repeat value will be removed too. So 1 and 9 will be left. Okay. So clearly, set difference is not a symmetric operation. We can also use the difference method to calculate set difference. The operator is the hat key. Let's see, primes had Oz. Okay. So the symmetric difference is the set of elements that are in only one of the two sets. So they are either in primes but not in Oz, or in Oz but not in primes. Okay. So that's why it's symmetric. We can check it. Oz had primes. So there is also a symmetric difference method. Okay. And you can also change it the other way. All right, that's all for today. And next time, we will talk about NumPy data structures, vectors, matrices, and arrays. If you think this video is helpful, please like it and subscribe my channel. Thanks for watching. See you next time.